Okay, good morning students. As you know, my name is Suraj Pandey and you are floating with me in the world of physics. So we are going through a chapter. As you know, your chapter name is fluid mechanics. So in that particular chapter we have a new heading for you, and the heading is your flotation. So what do you mean by flotation? What is the basic sense of flotation? Each and everything we will discuss in this lecture in detail. Okay, so let's get started. Firstly, we will see that what do you mean by the flotation. So basically, if we talk about that, we have a container, let's suppose like this way. Okay, and in this container we have some fluid like this way. Okay, so let be this is your any fluid you took for the experiment. Okay, and now it's time for put a body in it. Okay, so there may be three conditions rises. Let be that firstly this be your body in this position, let be the position A. Okay, and maybe the body will be at position B like this way. Okay, or let the body be in this position. So mainly we can say that there are three categories we have. That means under A category, body floats, we can simply say body floats. Okay, or in condition B we can say that partially floats, and in condition C we can say body dipped completely. Body dipped in the liquid. So basically three conditions arises when you place any body in any type of liquid or any type of fluid. Okay, so why we can say that body floats on any fluid, why it partially dipped, or we can say partially floats, or why it completely dipped inside the fluid. So this is basically depends, or this is basically called the flotation. So here in this topic, in this chapter, in this lecture, we will discuss that what is the reason behind the flotation. So as we can simply say that we have different things are here. Okay, so we have different things. What are those things? We have number one, you have a body. Okay, so first is your body, and second one is your, you can say, your fluid what you have took for your experiment. So if we consider that the density of the particular body can be taken as sigma, and the particular density of a fluid is taken as rho, so in this condition we can write that if sigma is less than rho, then what will happen? If sigma equal to rho, then what will happen? And if sigma is greater than rho, then what will happen? So I hope that few of you can easily guess that we have three conditions. At condition A, body floats; at condition B, partially floats; at condition C, the completely dip. So the same three conditions verified by the three conditions in form of density. So if sigma is less than rho, then we can say the body floats only. If rho is equal to sigma, then we have the condition that it partially floats, or we can say half will be inside the fluid, half will be outside the fluid. And if the density of the body is greater than the density of the fluid, then we have that the body simply dipped inside the fluid. Okay, so this is basically the concept of flotation. Means we can simply say that the body can float, or it can dip, or it can partially float inside any fluid. This matters only the density. It means the different values of the different materials, and the different values of the different we can say fluids have the three big major categories as you can see here. Okay, so I hope that this thing is clear to all of you. Now we will come to the next topic. As you can see that your next topic is pressure difference and buoyant force in accelerating fluids. So what do you mean by pressure difference and what do you mean by the buoyant force? As in the previous lecture I have told you that when anybody is inside any fluid, then the fluid applies pressure from all the possible directions and perpendicular to the surface of the body. Okay, so basically the resultant of that force which is due to the pressure of the fluid is we can say generates a resultant force, and that resultant force is the buoyant force and the direction is upward. So these thing is already I have mentioned you in the previous lecture. So what we have here that if any object is inside a container, let's suppose this be the object, then a buoyant force, let be buoyant force B. Okay, so a buoyant force capital V will be acted upward, or we can write FB. So it is more convenient to all of you to understand that FB represents the buoyant force. So the direction of the buoyant force will be upward. So I hope that this thing is clear to all of you. Okay. Now what? As you can see that we have to calculate the buoyant force or pressure difference, and the condition given to you that the fluid must be accelerating. So what is the basic sense of the acceleration? You know that there must be the change in the velocity. Okay, if there is a change in the velocity, then we can say the body is in acceleration. So here in place of body we have to take the fluid. Okay, so the question is how we can accelerate the fluid. What is the basic method to accelerate the fluid? So we have several methods to give the acceleration, to provide the acceleration by applying the certain forces in that particular fluid. Okay, so one very convenient or very general example is as you all know that we take the example of lift. Okay, so basically why we take the example of lift? Because we can say that lift is considered as a framed body. Okay, so we and also we can easily calculate the acceleration of that particular lift. Okay, so for the we can say the better understand, we generally take the example of the lift when we have to study about the frame which is accelerating. Okay, so the lift is a frame which is accelerating, and inside that lift we will put the fluid of the experiment. So as you can see in this diagram, okay, so this is your basic diagram. In it this is your lift, and in this lift this is a container. Okay, so this is your container, and in this container you have a fluid. Okay, so where is the fluid? Fluid is this one. I hope that it is now visible to all of you. Okay, so this is the fluid basically. So here, okay, so this is you can say that a fluid is there, and where is the body? You can took that this is your body. Okay, so the vertical shape is considered here because we have to calculate the pressure difference. Okay, but if we have to calculate only the buoyant force, then there is no requirement of taking any cylindrical body or the body having some definite horizontal distance or vertical distances. Clear? But here we have to calculate the pressure difference, so it is necessary that you should take a body which have certain length. Okay, so if we talk about the body which is in the shape of a cylinder. So firstly rough this diagram, and now draw another diagram. So this is your body which is inside the container, as I have discussed here in this main diagram. Okay, so in that particular diagram we have one force which will be on the upper edge of the body, and the concept is clear that the force must be due to the pressure of that fluid. Okay, and also we have another force, that is F2, and no doubt it is also due to the we can say that due to the pressure of the fluid. Okay, so we know that the basic formula of the pressure, that is pressure equal force upon area. Okay, so in place of force we can take pressure into area. Okay, now what if we take that the F1, so that will be P, and pressure is different because the height is in vertical direction, so it can be taken as P1, and area is quite similar of the upper edge as well as the lower edge, and F2 can be taken as the P2 times A. So we have F1, we have F2, and F1 equal to P1A, and F2 will be equal to P2A. So this is the basic formula, as you know very well. Okay, and by using this formula we can easily calculate the force that will be P into A. Now what? We know that if it is a body, so there must be a weight of the body, that is the capital W. And as I have already told you that the container is inside a lift. Okay, so if let me the dotted line represent the lift, as you can see in your main diagram. Okay, this is your main diagram. So if this is your lift, and that is moving with the acceleration A naught. Okay, then what you can take, what you can took here, that simply we can take that there must be forces F1, and the F1 force is in the downward direction, and also capital W, that is the weight of that container, that body, and the body is basically represent the fluid. Okay, so that is the weight of the fluid itself. Okay, and then we can have another force F2, and that is in the upward direction, so that will be minus F2. So these are the forces which is applicable on the body which is assumed in the fluid, and the net force is always equal to mass into acceleration, as we all know, so it can be written as mass into acceleration. So the few of you can be confused that why we have not considering here FB. The answer is quite easy, because we have already taken as F1 and F2, and we know that the resultant of F1 and F2 is FB. Okay, so either you can took FB, or you can take F1, F2. So one time you have to choose any one parameter. Either you can write your Bion force only, or you have to differentiate the Bion force in F1 and F2. So basically we have a equation that F1 minus F2, and that will be MA naught minus capital W. So I hope that up to here each and everything is clear to all of you. Now we have equation that F1 minus F2, and that one is equal to MA naught minus W. So MA naught minus W, and we also know that weight is nothing but equal to mg. Okay, so it will be F1, and F1, as I have already told you, that F1 is equal to P1 times A. So you can write here P1 times A, minus P2 times A, and that will be equal to M A naught minus mg. Okay, so if we take A common here, then we have M also common here, A naught minus small g. Now we know that in place of mass we can took the density in terms of volume. So we know the basic formula that density is equal to mass upon volume. So we can write that mass equal to density into volume. So that will be density into volume times A naught minus G, and that will be equal to P1 minus P2 times E. Now you can easily understand that if we, in place of volume, if we place the equation of volume, that is the area into length or height, whatever is there. So let be the height of that particular cylinder, what you have assumed here, that be h. So in place of volume you can write area into height times A minus G, and that will be equal to P1 minus P2 times A. Now it is quite easy to understand that now we have to cancel out A to A, and we get the pressure difference P1 minus P2, and that is equal to rho times H times A naught minus G. So this is the pressure difference what we have discussed here only. Okay, so basic thing what we have learned here, that we have a container, we have a body, what we have assumed here, that and the body also represent, we can say, the fluid itself. Okay, so in either way you can consider, because whatever because here we have to calculate the pressure difference in accelerating fluid only. Okay, so how we can calculate the pressure? So in that situation we have to certainly consider a body inside the fluid. Okay, and the body whatever is inside the fluid also we can say that felt the pressure which is due to the fluid itself. Okay, so I hope that the basic concept is clear. We have to calculate the pressure difference. We know that if the body is in vertical position, then there must be different position on its edges. The upper side will be at lower pressure, and the deeper side will be, we can say, at the higher pressure. So basically we have two pressure, one is P1 and P2, and if we consider that P2 pressure is in deeper edge of that particular body, it means P2 must be greater. So we have to write that P2 minus P1. Okay, so the pressure difference here you can write P1 minus P2 or P2 minus P1. So this depends upon the basic situation, basic condition, that what you have considered here, that your left is moving upward, moving downward, or at rest position. So each and every condition is justified in this equation. So I hope that these two topics, first is your flotation and second one is your the pressure difference in any vertical column which is inside a fluid which is accelerating. Okay, so these two topic is clear to all of you. Now what we have to do now, you have to go through these two derivations deeply. Okay, then try to learn it by yourself, try to solve this expression what I have already derived for you. Okay, now you can also try some numericals based on these two topics. We will discuss the few more topics in the next lecture. So thanks for watching me, thanks for listening me, and best of luck.